All right, the next section is 8.3, proving triangles similar. Now, we're not actually going to prove it using a two-column proof, but we do need to show why things are similar. So what we need to know to say two figures are similar are that the corresponding angles are congruent. The other thing we need to know is that we have proportional sides. Now, we learned this in 8.2, but here's more information and a reminder again. Congruent angles and proportional sides. Now, we're going to look at our different postulates. Our first postulate is angle-angle similarity postulate. Now, take note of how we write that. We write AA and then the little similarity sign. And it says if two angles of one triangle are congruent to two angles from another triangle, then the triangles are similar. So that means if I have these two angles similar and these two angles are if this angle is congruent to this angle and S is congruent to P, then that means I have angle-angle similarity. And again, it is AA with a similarity sign. The next one is side-angle-side similarity theorem. So it says if an angle of one triangle is congruent to an angle of a second triangle, then the sides including the two angles are proportional, then the triangles are similar. For example, if I have side angle side and side angle side, and these two sides are congruent, then I know, or to these two sides, then I know that using side angle side, we have side angle side similarity. Again, we have side angle side with the little similarity sign. Now, the most important thing about labeling these theorems is to make sure you write this similarity sign. If you don't write the similarity sign, then it will be a point off on your test or quiz. Now, the last one is side-side-side similarity. So, it says, if the corresponding sides of two triangles are proportional, then the triangles are similar. For example, if I know that 4 over 8, so I'm using my little side in comparison to my big side, is equal to 6 over 12. So I have 6 over 12, which is equal to 2 over 4. All of these reducing to 1/2. So if the corresponding sides of the two triangles are proportional, which they are because they have the same similarity ratio, then the triangles are similar. And this is side, side, side similarity. Again, don't forget your similarity sign. All right, now it says, are the triangles similar? So we are going to try to prove that these are similar using one of our three theorems. And we have our three theorems are angle-angle similarity, and then we have side-angle-side similarity, and then we have side-side-side similarity. So now we remember that these two angles are congruent because they are vertical angles. So now what I need to test is to make sure that I have proportional sides. Now when I look at this, I'm going to have to, or this side is like my long side, so it has to be proportional to my long side on this triangle. So I have 18 over 36, and that reduces to 1/2. And then I also have 12 over 24, because I have this over this. That also goes to 1/2. So then I can say that these two sides are proportional and these two sides are proportional. So by side, angle, side, I can say that they are similar. Now the next one. We need to know if these are proportional. Now, I'm going to have to use side, side, side because they gave me three sides. Now, what I need to notice is that my biggest sides should match up with each other. For example, I should have 6 over 8, because those are one of my little sides, and then 9 over 12 are my big sides. So I have 6 over 8, which reduces to 3 over 4, and I have 9 over 12, which also reduces to 3 over 4. And 6 over 8 happens twice, so I don't really need to do that ratio again. So if all of my sides are proportional, which they are because my similarity ratio is 3/4 for both of them, then I should be able to say by side, side, side similarity that my triangles are similar. Now I want you to do this next one on your own, and I will check it tomorrow in class. Okay. Next example. It says, if the triangles are similar, find the missing side lengths. So what I notice is that this triangle is just a portion of my big triangle. So if I am doing a proportion, then I can say 12 over 16 is equal to 7, because 12 goes with 7, that's my small triangle, over, and now my whole length of my side is 7 plus x. So I have 7 plus x here. Now, I have 7 times 16, which is 112, is equal to 12 times 7 plus x. Now I have to distribute. Now don't forget to make this set of parentheses around the 7 plus x, because otherwise I would have 12 times 7 plus x, and that doesn't make any sense. So I have 112 is equal to 84 plus 12x. And then I subtract 84 from both sides, so I have 28 is equal to 12x. And then I divide by 12 on both sides, and I get 28 over 12 is equal to x, and this is going to reduce down to 7 over 3. Now, I want you to do this next problem, and once you do this next problem, tell me what the similarity ratio was, and I also want to know what theorem or postulate you used. Have a good night.